In this video, I'd like to draw a little bit of what might be called a mind map to show how I see these things, these different quantities and concepts to be connected. So it might help you as you organize your thinking about these ideas. So we've been looking most recently at unbalanced forces. And when there are unbalanced forces, we found that the object would have a changing velocity. Well, change of velocity per unit time, that is acceleration. Which has the symbol A. And from kinematics, we have a whole bunch of equations that relate velocity, distance, time for situations with a constant acceleration. So our constant acceleration equations are delta x equals initial velocity times time plus 1/2 a times time squared. V final equals v initial plus a delta t. Vf squared equals vi squared plus 2a delta x, and then there's one more as well. So these are some equations, and now these equations then relate to velocity, they relate to delta t, they relate to delta x. Okay, so these equations connect acceleration and then these other variables. So unbalanced forces. How do the forces relate to the acceleration? So forces are related to acceleration by Newton's second law, which says that the net force equals the mass times the acceleration. And it's also written sometimes that the sum of the forces equals mass times acceleration. So just two different ways of writing the same thing. Now here we can see that we have forces, so this connects to the idea of forces. And we probably have a variety of forces that we've looked at. So one force we've looked at is the tension force. And we have talked about the force of gravity. We have an equation for that one. Force of gravity equals m times g. Or if you're on other planets, we have the Newton's law of universal gravitation, which is more general, g m1 m2 over r squared. So this is just for the surface of the Earth if we're using 9.8. And then we have, let's see, we have the normal force, which is when surfaces are pressing together. We call that Fn. And most recently, we've been looking at the force of friction. And with the force of friction, we found we have two kinds of friction. We have static, for when an object is not moving relative to the surface it's on, and we also had kinetic for when an object is moving relative to the surface it's on, so sliding. And we have the force of static friction maximum equals the coefficient of static friction times the normal force. And for kinetic friction, we have force of kinetic friction equals mu k times the normal force. And static friction can have any value up into this maximum. So static friction can have many values up to this maximum. And also about static friction, to get an object to move, you have to overcome this maximum static friction force. And once it's moving, it would have kinetic friction on it. And I see another connection here, which is these are related to the normal force. So these relate to the normal force. So this gives a little bit of a mind map to show some of the relationships between these different quantities. And when you're solving problems, if you're given a lot of kinematics information, you're probably going to be starting over here, finding acceleration, using acceleration to find something about the net force, and then working with the forces from your free body diagram to figure out the details of what you're being asked for. If you're given a lot of information about forces, you're given coefficients of friction, values for those, then you might be working your way this way, maybe to find the time it takes something to stop, or to find the acceleration of an object.